Hello, Northwood students. This is the LEAP help videos on geometry. So this one today is going to be on midpoint and distance. So let me go ahead and share my screen so we can talk about that. So one thing I want to let you know when you're talking about midpoint and distance is you can talk about midpoint and distance on a number line. So we could be asking A to find the midpoint and distance of some number line, or we can also be on the coordinate plane, the XY coordinate plane. Also called the XY grid sometimes. And depending on which one of these you're working on, that's going to make the work different. And it's also going to make formulas different, things like that. So let's first talk about midpoint. And we're just going to do part A first, midpoint on some number line. So the number line, remember, is just a list of numbers. It can start anywhere. Oh, sorry, it wouldn't go that way. That'd be a 1, 0, 1, 2, 3, 4, 5. So the numbers can start anywhere. We always put the smaller numbers on the left, however, and then they're going to pick out 2 points and ask you to either get the distance or the midpoint. So when we talk about midpoint, an important thing to understand is midpoint is halfway, midway, or halfway. And another thing to recognize that if you're at the midpoint, you've broken your number line or your segment that's on the coordinate plane, broken it into 2 equal parts. And that's used a lot when you're doing these midpoint problems, that fact. Okay, so if we're on the number line, it's really simple. You just take an average of the endpoints. So the formula or the process is take the average of the 2 endpoints. So if you remember from algebra, to take an average, we also call that a mean. It means add up all the items and divide by the number of items. Well, if we're only taking of 2 endpoints, we've only got 2 things to add. So we're adding those 2 things and dividing by 2. This always gives us the middle. So in formula wise, if you in your textbook or in your geometry class, your teacher probably taught you the formula, the generic formula, if you will, or the abstract formula. And these things mean sub 1, 0.1, 0.2, x sub 1, x sub 2 means 0.1, 0.2. And so you just take your 0.1 plus your 0.2, again, add them up and divide by 2. The only thing you have to be really careful about is if you're going to use a calculator for this, you do need to parenthesize the top if you're going to put it in a calculator before you divide by 2, or the calculator may give you the wrong answer. So here would be an example. If I take the number line, starting at 2 and going to 10, and if they don't tell you any different, you can just assume these are single marks in here, and they won't always fill in all the marks in between. But let's say I want let's call this point A and point B, and let's say I want midpoint of AB. So if I want the midpoint of AB, we're going to go back up here to the formula that we just talked about, and we're going to take point A to plus point B, what number it's at, 10, add those up and divide by 2. And, I don't really need a calculator for this, but like I said, if you did, make sure you parenthesize that in the calculator. So 12, just as easy to do some of these by hand though. So 12 divided by 2 would be 6. And so that means that at 0.6, we should be right in the middle of 2 and 10. Let's count it out. So 3, 4, 5, 6. So here's the midpoint of this number line right here. Now, remember what I talked about a minute ago, that if it's the right midpoint, that means this from from 2 here to M, we'll call it the midpoint, is the same distance as from the midpoint to 10. Well, if you think about it, this is 4 away from 6, subtracted though, and this is 4 on the plus side of 6. 6 minus 4 would give us 2. 6 plus 4 would give us 10. And that's a way you can check to see if you actually did the formula right. Now, this is a formula that is not given to you on the LEAP. There are so many formulas in geometry that you're not given on the LEAP that you really want to make sure you sit down and look at those formulas some days before you take your test. Alrighty, let's move on to midpoint on a coordinate grid or coordinate plane. And of course, when you're on the coordinate grid, we're talking about the grid that looks like this, that has an X and a Y. And our coordinate points are going to have, they're going to have an X coordinate point and a Y, X component and a Y component. So because of that, the formula is going to be a little bit different. Let me go ahead and write the formula out first. So the formula is X sub 1 plus X sub 2 over 2, kind of like what we started with when we did midpoint on the number line, but we also have Y's to deal with. So we're going to do it a second time with the Y coordinates. The Y's are the second number in the parentheses. So Y sub 1 plus Y sub 2 also over 2. And again, this is going to give us an answer that is a coordinate answer. For example, you might get, -1, 3. So you're not going to put those together and try to add them together to become 2 or anything like that. Now, when you're looking for a midpoint on the coordinate plane anyway, it is an actual XY point. Let's look at an example of that. Okay, so I have the example 2, 5 and -3, 1. And I'm asking for the midpoint of these two coordinates. We are going to do a little graphing in a minute just to show you how some of these problems could be done graphically. Okay, so again, this is your X and this is your X. You can call this X sub 1 and this one X sub 2. It doesn't matter which one you pick for X1 and X2. We'll call this Y sub 1 and Y sub 2. What's important is you make sure, I tell students to draw little lines to the first two to help make sure you understand that these are the two that have to go together. You never put these two, you don't put the 2 and 5 together. You're going to put the first two things in the parentheses together. Those are your X's. So 2 plus, say, -3 over 2, and this is all a coordinate point in itself, 5 plus 1 over 2. Again, if you're going to put in the calculator, don't forget to do the parentheses. That's going to equal a 2 plus a -3 is going to be -1. I teach my students if they're unsure about this and it's a no calculator part of a test, you can put down little counters. So if I put down 2 positive counters and I add on 3 negative counters, everywhere you have a positive and a negative, that turns into a 0. So we just cross them out. And you can see that that just leaves you 1 negative counter. So that is a -1. If you have a calculator, it's no problem, but part of your test will be no calculator. We don't need to change that to -0.5, although you could. And then 5 plus 1 is 6. We do, however, need to change this one because this is a even number over 2, and we know that that can be divided evenly. And what that's going to give us is our final answer, 1/2, 3. And, it's not like they couldn't put -0.5, or I guess it would be 0.5 more technically, but, you might see it either way. But nothing wrong with leaving this number as a fraction. Okay, so you also can graph, and you are going to get graph paper when you take the LEAP. So it's a good idea to know a little bit about how to use graph paper. So let me just show you a little bit about midpoint and how to graph. If you've ever done, when you were doing slope and you had to make a slope triangle in Algebra 1, it's kind of the same method almost. So I'm just going to make up a new problem, but we're going to work it totally on graph paper. Or I really could have taken this problem I just did and put it on graph paper to check it if you just want to make 100% sure that you got it right. All right, I'm going to take the points -1, -4, and, oh, I don't know, 3, 6. Okay, so if you're trying to do midpoint graphically, the first step is going to be to plot the points. All right, let's do that. So -1, 4 is to the left. Remember, you always go right or left to get this first motion, and then up or down for the second motion. So from the origin 0, 0, we're going to go left 1 and down 4, 2, 3, 4. Okay. And then for 3, 6, we're going to go over to the right 3 and 1, 2, 3, 4, 5, 6. Your teacher might have taught you have to walk into the elevator before you go up or down to help you remember that. Okay, the second thing you want to do is to connect the points. And the reason you want to connect the points is because you can almost visually see about where the midpoint is going to be. So I can kind of see, that my midpoint is going to be somewhere right along in here, possibly. And if you say you had already worked the problem out, and maybe you got -1, 2, and that would be right here, well, you're nowhere even on the line segment. So if you have your line segment connected, then it'll help you try to see if you've gotten your problem correct or not. All right, so if you're going to try to find the midpoint, let's say we're not even working it out mathematically, after you connect the points, you're going to make a right triangle. Now watch me carefully so you can make sure you understand. You can't just make a triangle wherever you feel like it. You have to follow horizontally and vertically from the points until they connect. It's not a bad idea to get a protractor to help you with this. So follow along and make the right triangle until those two connect. So there's my right triangle. And so what's happened is, to get from this point, let's just call this point A and point B, to get from A to B, we have traveled to the right so many units and up so many units. And if we want to go to the midpoint, we can just go half of that traveling. So let's count. 1, 2, 3, 4. Let's go ahead and write that down. I've gone a distance of 4 over to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've gone 10 up. So you want to take in half those numbers, because we're going halfway. And if you do a motion of 2 over and then 5 up, you should get to the midpoint. Let's try it. 1, 2, 1, 2, 3, 4. And you see it's right where I thought it would be. Visually, it looked like it would be about there, and it does work out. Now, let me tell you the only downfall of this graphing method. Sometimes the numbers are going to be too big, and graphing is not going to be as useful, or sometimes you're going to have decimal answers, and it's a little bit harder to do the graphing when you have decimal answers. But if that happens, you can always work it out with the formula and then just go back and check it with graphing. But every now and then, when you get a nice problem like I just had here, I didn't have to do anything. I can tell now the last thing you have to do. So let's finish our steps. So after we made the right triangle, we counted the sides of the right triangle, or the legs, we should say, and then move half as much. But we do have one final step, and that is, what point is this? So they're not going to, take your graph and grade this by what you've done graphically. They're going to have some answers you're going to go pick from. So we need to go back in from the origin and find out what point this is. Well, it's 1 to the right and 1 up. So the midpoint in our case is 1, 1. And, if you did the math of it, it would also check out. Okay, let's move on and talk about distance. Now, remember, we can do the same thing with distance. Distance can be, move some of this out of the way. Distance can be on a number line. On a number line, or it can be on the coordinate grid. And I'll also show you a little bit with graphing for distance. Okay, so we're doing now distance. of 2 points. And again, it can all, let's do the on a number line first. And let's just go back to the example that we did a minute ago. So the example we had a minute ago, we had 2 and 10. So when you're trying to find distance on a number line, the process is to subtract the endpoints, but with one really important exception. Your answer has to be positive. So if you subtract and you get a negative answer, then you're just going to take the absolute value and make it a positive answer. We're never going to have any negative answers when we talk about distance. And if you'll always come over to the larger number first when you subtract, you won't have any negative answers anyway. So it would be 10, if we call this point A and point B. We want the distance of AB, and that's what that looks like. It's AB without any line over it. So we need to do 10 minus 2, which is 8. And again, if you accidentally took the number toward the left, you would get -8, but we always turn that back to a positive. So the distance between these 2 points on the number line would be 8. Again, it's countable here. 1, 2, 3, 4, 5, 6, 7, 8. But you do need to have knowledge of this formula in case it's bigger numbers. You could also write this abstractly if you want, just like we did when we did the midpoint example. So if we call this x1 and x2, and we're trying to find the distance, they're actually going to put the formula in absolute value bars. And that's just the part I was talking about, that your answer is always going to be positive no matter what. So don't get confused by the absolute value bars. Just take these 2 endpoints and subtract them, and just make sure you always write your answer as a positive. Okay, distance on the coordinate plane is probably the hardest one, only because the formula is a little more involved. Let me go ahead and show you the formula. Coordinate plane, or the XY grid. So here's the formula. It's D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1. Y'all, again, another formula that is not going to be given to you on your LEAP. So you do have to have this formula memorized. I am going to show you graphing, and when you graph, you actually use the Pythagorean theorem. So some of y'all probably already know that formula, but if you notice, this looks a lot like the Pythagorean theorem. This part would be your A, right? This subtracting the x's is your A, so it's A squared plus this part would be your B, B squared. And we just took the square root because remember in the Pythagorean theorem, it's C squared equals A squared plus B squared. To get just C, we always take the square root at the end of the Pythagorean theorem anyway. So that's why this thing reminds you, and that makes it a little bit easier to memorize if you'll think about it looking a lot like the Pythagorean theorem. Okay, let's look at an example with numbers, and then I'll show you about graphing. Let's take -2 comma 7 and -3 comma 4. And again, I want the distance. So let's call these just AB again. And when you want the distance, it's just going to have the 2 letters. Remember, 2 letters represent a segment, but if they don't put a line over it, that means they want the distance of it, or the length. All right, let's see if we can put this into the formula. I tell my students, instead of necessarily labeling this x1, y1, x2, y2, I always take and draw arrows, because you do have to be careful about order on some of this. And so that will make sure that you're careful about the order and go this way. Because when we get to slope, if you're not careful about the order, it'll mess you up. So you might as well get used to going in a certain order. You could go backwards if you wanted. So my formula is going to have x's of -3. Now there's a minus from the formula, and then there's another negative in front of the 2. So that's going to be a double negative, which is going to turn positive. And then 4 minus 7. So there's my result before I do any kind of simplifying. All right, now here is a really, really important thing to understand. And I'm going to go ahead and get a calculator to show y'all this. Let's simplify one more step before we do this. So this will be, again, a -3 minus a -2 is going to turn into -3 plus 2. That's kind of what we had a minute ago. That will be a -1 squared. And 4 minus 7 will be -3 squared. Now, I want you to look at something important on this calculator. If you're going to use your calculator and you put -1 and you square it, see if I can get where y'all can see that. That gives you a -1, but that's not the right answer. A negative times a negative turns positive. And if I do it by hand, -1 times -1, which certainly you can, and let me get the glare off of here, then you see it does give me what I'm supposed to get, a positive one. And the same thing would happen with the other -3 squared. If you don't parenthesize it, the calculator can't understand what you want it to do, and it accidentally gives you the -9. But if you parenthesize it, sorry, I got to close my parentheses, and then you square it, it gives you, no, sorry about the glare, gives you the correct answer of +9. So anytime you square a number, you're always going to get, when you work the last step of the distance formula, you're always going to get two numbers that are positive numbers. Oh, sorry, that's a 9. Apologize. So 1 times 1 is 1. -1 times -1 is +1. -3 times -3 is +9. And then that answer is just going to be the square root of 10. They may turn that into a decimal. So if they do, you're going to have to know how to use your square root button on your calculator. I hope you guys already know how to do that since you've been in Algebra 1 and Algebra 2, but I'll show you real quick. I'm going to zoom in and try to get the glare off this calculator. So if you're trying to do the square root, you're going to have to hit the button right here first. This is the second button. And then you come down here right beside the 7 and hit that button. And you see what happens? It actually pulls up the square root symbol, and then you put in whatever number you're working with. Our number is 10. And a lot of times they're going to want you to round that to the 10th. So we're going to look at this number right here, the 6. Since it's bigger than, it's 5 or bigger, I'm going to round that up to a 2. That answer should be 3.2. If this was like 3.12, then it would stay, your answer would be 3.1. So my decimal answer should be 3.2. Again, that's how you do the distance, and a lot of important things about it as far as calculator work, but also formula memorization and such. Now, let me go back and show you about, we're going to just check this one graphically. We're going to make sure we got this one correct graphically. So when you're talking about distance on a coordinate plane, if you got in the test and you blanked out and you didn't remember the formula, because it is pretty brutal, almost everybody knows Pythagorean theorem. A squared plus b squared equals c squared. It's just an easy formula to memorize. Well, if you graph these points and make a triangle like we did earlier with midpoint, you can turn this into a Pythagorean theorem problem. Let's do that. So let me go and get my coordinate grid. Okay, so I'm going to go to the left 2 and up 7. I'm going to go left 3 and up 4. All right, and then this is going to be a really skinny triangle, and that's okay. So there's my segment I'm talking about. And when I make my triangle, remember, you're going to go down vertically and over horizontally until these two things meet, just like we did for midpoint. We're going to count 1, 2, 3, just like we did for midpoint, and 1. But instead of going halfway or doing any of that, that's not what we're asking for. We're not trying to find halfway. We're trying to find how long this is. Well, now I can just put the two legs of the triangle, because we're basically looking for the hypotenuse of a right triangle. So I can do 1 squared plus 3 squared equals c squared. And if you notice, it's not a coincidence that these numbers are very similar to what I had right here. They are going to be positive numbers instead. Still going to work out to give us the same answer. 1 times 1 is 1. 3 times 3 is 9. So c squared is 10. But when we're doing the Pythagorean theorem, we always have to take the square root at the end to get rid of, we don't want c squared, we want what c is. So those two things cancel out. So this will be c is just the square root of 10. Again, same answer that we got a minute ago, just using a little bit of a different method. All right, folks, I hope that helped remind y'all about midpoint and distance. Please be watching out for some other videos that we'll be doing on these other geometry concepts.